Continuing with our discussion on temperature and heat, this time we have conservation of energy, in particular conservation of heat energy. When analyzing the temperature change and phase change of objects in an isolated system, we can use the conservation of energy principle. Conservation of energy principle, heat is a form of energy. Heat may be converted from one form to another. It may be converted to kinetic energy or it may be converted into work and vice versa. Heat is neither created nor destroyed. It must come from somewhere and it must go somewhere. It simply will not just appear out of nowhere or disappear into nothing. And the total energy of the system is constant. In this case, the total heat change of the system must be equal to 0. Q gain plus Q loss is equal to 0. So take all the Q gain. Q gain is positive by convention. So take all the positive Q, add them all together, and you have Q gain. So take all the Q due to temperature increase and Q involved in melting and boiling in the system. Add them all together and you have Q gain. Temperature increase is simply mc delta T. So take all that mc delta T for temperature increase. Q melting and Q boiling are phase change. Melting, you have positive MLF. Boiling, you have positive MLV. So you just have summation of all the positive ML, whether you have LF or LV. So Q gain is just equal to summation of all the MC delta T plus summation of all the positive ML in the system. Again, MC delta T will be positive for Q gain. So automatically the equation MC delta T will tell you that you have positive Q, whereas in ML, you yourself will have to determine if there is melting or boiling that is happening in the system. You yourself will have to determine that positive sign. You yourself will have to assign that positive sign to the equation. Do the same thing for Q loss. Take all the Q negative in the system and add them all together. So you have Q from temperature decrease, Q from freezing, and Q from condensing. That will give you Q loss is equal to summation of MC delta T plus summation of negative ML. Since you have Q gain plus Q loss is equal to 0, conservation of energy. So you have Q gain plus Q loss, which will give us the following equation. Summation of MC delta T plus summation of all the plus minus ML. Again, depending on the situation, you'll either have LF or LV. So summation of all the plus minus ML is equal to 0. Conservation of energy principle applied to the isolated system. It involves all the objects in the system. Look at each object in the system and determine if it undergoes temperature change, whether it's temperature increase or temperature decrease, and you have Q is equal to mc delta T. Determine if each object has phase change. You have Q is equal to plus minus ml. Add all the Q's together, and the sum must be equal to 0. Summation of mc delta T plus summation of plus minus ml is equal to 0. And that's it for now. That's it for our discussion on conservation of energy. We'll continue our discussion in the next video, wherein we take a look at a few examples. So once again, that's it for now. Thank you for watching.